In lesson 2.5, we're going to be building logical arguments using some properties we already know. We already know properties of algebra, and so we're just going to go through those properties real quickly here to review what we know about them. And then we're going to use these properties to describe and give reasons for the steps of algebra problems. So if we look at the learning target, please spend the time to write down the learning target. I can use properties of algebra and logical arguments. And the properties that you already know are the addition property, where we say that if A equals B, then if we add C to both sides of the equation is still in balance. So if, for instance, we know that 4 equals 4, but if I add something on both sides there, like let's just say we add 1, 4 plus 1 equals 4 plus 1. Okay, so that's all we're saying in each one of these properties is we can do the same thing to both sides of the equation. So for the subtraction property, we know that we can subtract the same thing from both sides. So if A equals B, then A minus C equals B minus C. Same thing with the property, the multiplication property. We can multiply both sides by the same thing. And in this statement it says if A equals B, then A times C equals B times C, because we can multiply both sides of the equation by the same exact number. Division property states that we can divide both sides by the same, except we cannot divide both sides by 0 because that just results in a undefined number, so we can't divide by 0. But we can divide by anything else, and if we divide both sides of the equation by the same thing, then the equation is still in balance. The substitution property says that if A equals B, then A can be substituted in for B in any equation or expression, and that would work the other way too, so B could also be substituted in for A. Distributive property states that where A times B plus C, it's going to be A times B plus A times C, because we're distributing the A, which is outside of the binomial, the parentheses inside the binomial. Okay, so we know that we can do those things. Now we're going to learn a few new properties. One of them is the reflexive property. The reflexive property applies to real numbers, it applies to segment lengths, and it applies to angle measures. So remember, segment lengths are written in this form, and angle names and angle measures are written in this form. So it says that the reflexive property for any real number, A equals A. So what you can see here is that we're saying that numbers are equal to themselves. So reflexive just means equal to itself. Okay, so this is kind of like a mirror. When you're looking in the mirror, you see your reflection. It's yourself. You equal you when you're looking in the mirror. So think of a mirror here. Something is reflecting back to itself. So numbers equal to themselves, segment lengths equal themselves, and angle measures equal themselves as well. Okay, another new set of properties, the symmetric property. The symmetric property of equality applies to real numbers, segment lengths, and angle measures. And if you want to think of this one as just switching the information, you can do that. So if you take a look at, for any real numbers A and B, if A equals B, then B equals A. So here we're just going to switch the information around, and that is the symmetric property. So you do need to remember the symmetric property, you switch. The reflexive property is something is equal to itself. So like we said, real numbers, if A equals B, then B equals A. For any segments, if AB and CD equal each other, then that means it could be written either way. AB equals CD or CD equals AB. We're just switching the order of how it's written. We can do the same thing for angles. If measure of angle A equals the measure of angle B, then if we write it this way, it means the same thing and is exactly the same. Angle B equals angle A. Alright, so the transitive property, the last new property that we're going to learn, still applies to numbers, segment lengths and angle measures. And you can kind of think of this one as, like we learned about the law of syllogism, if something is repeated, we can delete that portion and then the remaining part is still true. So it's like the law of syllogism, because if A equals B and if B equals C, then we can just delete the part that's repeated and what's left is still true, A equals C. Because B was part of this equation, B was part of this equation. So if we take it out, we see that A is equal to C. And that's true for segment lengths as well. If segment AB equals segment CD, and then CD equals EF, well then that means that AB equals EF, because look at this, is repeated. So if these two, because they're the same thing, equal this one and they equal this one, then that means those two equal each other as well. You can just take out the part that's repeated, sort of like we did with the law of syllogism statements. Angle measure, if angle A equals angle B and angle B equals angle C, then you guys know that angle A equals angle C, because the repeated angle can just be removed and these two can be equal to each other. Okay, for example 1, it asks us to write the reasons for each step. The reason is going to be a property, one of the properties that we just went over. So you're going to need to write the property in on the line. In the very first step, it says write the original equation. Well, the original equation came from up here. It's telling us to solve this equation and write a step for each reason. So whenever we start a proof, the very first step is generally, the reason is generally the word given, because we were given the information from the beginning. So there's not really a reason for that first item, it's just that we were given this information. So in the next step it says 3x minus 6 equals x plus 4. Well, how did we get from this step to this step? Yes, we multiplied, however we didn't multiply the same thing on both sides, but what we did do is we distributed that 3 to the x and that 3 to the negative 2. So it looks to me like we did the distributive property. Okay, you may be familiar with writing a reason next to your steps if you had Mrs. Finazzo for Algebra 1, because I think she was asking you to write each reason as you were solving. Alright, next step says subtract x from each side. Well, if we do the same thing to both sides, where we're subtracting this x and we're subtracting this x, then that's the subtraction property, because we just went over that if you subtract the same thing from both sides, that is the subtraction property of algebra. Okay, now it's saying we're combining like terms. There's not really a property for that, but another word for combine is simplify. Okay, so we're going to simplify the equation. And it says add 6 to each side. So when we add the same thing to both sides, that's the addition property. And then it says divide each side by 2. The rule that we use for that is the division property. And you probably have been doing these types of steps for quite a while, but maybe you did not really think about which property you were using as you did it. So the value of x for this problem is 5. And so that's what you're going to do on the next page as well. You're just going to complete the on your own. There are 2 problems for you to do. Let's take a look at the next page. And so you're going to be looking at doing this problem here, okay, and then you're also going to be doing this problem here. So the first step is just writing the equation in. So 2x plus 10 equals 7x. Okay, and as I said before, over here you're going to write the word given. So the next step, I want you to tell me what you're doing in this box here. Also write the information in the box underneath the equation, and then the reason is going to be the actual property. Okay, so remember the properties that we saw on the front side of the paper. Whichever property you're using, make sure you write it in there, please. And then also for number 2, the equation is going to be this. And then our first step, the reason is just going to be given. So as you move through the steps of the equation, please write your explanation in, and then also give a reason. So that would be either the addition property, the distribution property, subtraction, multiplication, division, depending on which step you're doing. And then of course make sure that you provide the value of x, because you are solving for x in each of these. If you have questions on this, please make sure you ask in class. And now we're going to do example 2. It says use properties of equality. So for this one, we're actually going to be looking at segments. And we can use the same types of properties for segments as we did for those algebra equations. If we take a look at the equation over here and then the explanation, we're still going to be writing in a property for the reason. We need to become familiar with all of the different properties that we were looking at on the front side. So in the beginning it says that in the diagram wy equals xz. So this wy equals this xz. Alright, well it has a little piece in common. If you haven't noticed there, that xy, this segment, is part of both of those segments that they say are congruent. So what they want us to show is that just the shorter part, wx, is also just congruent to this part yz. Alright, so to do that, they're going through some steps of explanation, and we're going to be looking at what they're explaining. So wy is equal to a segment wx plus xy. Okay, so when we add two segments together, that's just the segment addition postulate, and it didn't happen to be on the front side of this, but we know that we can add two segments together. We had studied this earlier in the semester, so this is the segment addition postulate. And for the next statement, it says that xz is equal to this smaller segment xy plus yz. So again, we're just adding two lengths together. That's still the segment addition postulate. And these will become easier the more times that you look at them, and you will also have a reference sheet that you can refer to as you're doing all of the assignments. And then we want to look at the next statement. It says that yw, or I guess I should say wy, equals xz. Well, that information was right up here in the very beginning, and if you see the word given, then you're just going to write in given. So we were given that information at the beginning, that wy is equal to xz. Okay? Now they're saying that we need to substitute this in for wy, and we need to substitute this in for yz. Well, if you didn't see this already, that information wy equals this and yz equals this was our first two statements. So because we stated that already, we can take this piece of information and set it equal to this information. Okay, so we're just substituting information for something else, and that is the substitution property. And the last statement here says that we're going to subtract xy from both sides. So if we subtract xy here and we subtract xy here, that's just the subtraction property, because we know that in algebra, if we subtract the same thing from both sides, then we're following the subtraction property. The statement is still equal because we've taken away the same thing from both sides. Alright, so we're just getting started. I know this is a lot to swallow just, as one big swallow, but we're going to break it down. We're going to be practicing lots of times, so Don't concern yourself too much if it seems like too much right now. And then if you have lots of questions, that's fine too. We could answer those. I'll give you some tips and tricks to remembering all of these things as we go along as well. The last two problems ask you to name the property of equality that the statement illustrates. I want to give you a hint that these two you can pick from reflexive, symmetric, or transitive. Okay, so don't go looking at any of those algebraic ones. It's either going to be the reflexive property, the symmetric property, or the transitive property. Okay, so do numbers 3 and 4, please, picking from the ones that I just mentioned. If you have any questions, I'll be glad to answer those in class.